In this second video, we study about the Ohm's law. So Ohm's law, do you remember that? So in your lower classes already you studied well. So V is equal to IR. So that is called Ohm's law. Here that Ohm's law can be derived from that equation. So current density equation, J is equal to sigma E. So from this equation we have to derive the Ohm's law. So let us consider the diagram. In this diagram, the cylinder like conductor is present. It can be connected to the battery. That battery gives the potential difference, that is V, and in this conductor the L is the length of the conductor and A is the area of cross section of the conductor, and the current can pass through in the one direction, that is in the clockwise direction, and also electric field is also produces along the direction of the current. So next we have to see the derivation of the Ohm's law. So derivation of Ohm's law. So V is considered the potential difference applied across the wire, and also E is the electric field, and L is the length of the wire, and therefore these three parameters are connected one of the equation, that is V is equal to EL. We are already studied in first lesson, that is unit 1. So V is the potential difference, E is the electric field, and L is the distance. So V is equal to EL. Therefore it can be rearranged, E is equal to V by L also. So already we know that the current density formula, J is equal to sigma E, that is the microscopic value of the current. So Ohm's law. So J is equal to sigma E is equal to, substitute the value of E value, E is equal to V by L. So sigma V by L. So rearrange that, J is equal to sigma V by L. So that is equation number 1. But you know that current density J is equal to I by A, that is the general formula. So J is equal to I by A, that is equation number 2. Equate these two equations and you will get I divided by A is equal to sigma V by L. Finally you have to find out the V value. So V is equal to IL by A sigma. So rearrange that, V is equal to I into L by A sigma. So V is equal to IR. R value, that bracket value, that is L by A sigma. So that is the value of R. So finally we find the value of Ohm's law. So V is equal to IR. But the parameters of R is equal to L by A sigma. So that is considered as the resistance. Here not a resistivity, that is R is a resistance, and here the 1 by sigma is also considered as rho. So the P like structure is rho L by A. So from the above equation, sigma is considered as the conductivity of the material. The reciprocal of this conductivity is called resistivity. So that is called rho. Rho is called resistivity, to resist the current value. So it can be lower the current value, resist, to stop. So sigma, conductivity, it can able to allow the free electrons. So conductivity is sigma, and rho is the reciprocal of the conductivity is called the resistivity. So in this previous equation, R is equal to L by sigma A. That is 1 by sigma is considered as a rho, that is called resistivity. So the SI unit of a rho is ohm meter, or we have to use the symbol also, cap symbol, meter, M. Then next one, resistors in series and parallel. So when the resistors, first one, resistors in series, see the diagram. So the resistors can be connected in a series. So three resistors are considered. So R1, R2, R3. So V is the potential. So it can be start from and end with the potential difference. So the different resistors value R1, R2, or R3, that can be have a different potential difference value also. So V1, V2 and V3. So here the current value is constant. So that is the concept. When the three resistors are connected in series, I is a constant, and for a different resistors the potential difference is also different. So resistors in series, I is equal to, general formula for Ohm's law, I is equal to V by R, that can be rearranged. V is equal to IR. So here I is a constant, R1, R2, R3 for different resistors for producing the different potential difference V1, V2 and V3. So here we have to split that. So that is the value of V1 is equal to IR1. So V2 is equal to IR2, V3 is equal to IR3. So we have to find out the total voltage for that. V is equal to V1 plus V2 plus V3. So you have to substitute the general formula on that total voltage value. So already you know that V is equal to IR is equal to V1 value IR1 plus IR2 plus IR3. Then finally you take the common value, that is I value, and cancel to that value. So RS is equal to R1 plus R2 plus R3. So this is the resistors in series value. Next one, the resistors in parallel. So we have to take the three resistors that can be connected in the parallel connection. So R1, R2, R3 like that. So when the potential difference is also connected to the R value, so it must be the same potential can be produced in all the three resistors, but the current value can be split in the for every terminals. So that is here V is a constant, I vary because of different resistor value. Let's see the derivation of that. Here resistors in parallel. So I is the separate paths for different resistors R1 and R2, R3. So through the resistor the different I values can be formed. Next V is a constant here, that is a potential difference. Then the total current, so the sum of the value of all the current value. So I is equal to I1 plus I2 plus I3. So you have to rearrange the Ohm's law like I is equal to V by R. So I1 is equal to V by R1 because V is a constant value. So I2 is equal to V by R2. Then I3 is equal to V by R3. Then finally substitute the value in the above equation. So above equation I is equal to I1 plus I2 plus I3. Then substitute the value of I, V by R. For I1 V by R1 plus V by R2 plus V by R3. Then take it out the common value V value. So V cancel for each term. Then 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that is considered as the parallel resistor. That is resistors in parallel. This is the formula. So the next topic, temperature dependence of resistivity. So here the resistivity depends on temperature, because when the temperature increases, the resistivity of the conductor is also increases. So for example, that can be, we have to see of the one of the expression. So this expression already they have to derive the scientist and given that. So you have to memorize this expression. So rho t is equal to rho naught into 1 plus alpha t minus t naught. So here I have to explain each one of the terms here. So rho t means rho suffix t. That means resistivity of conductor at T degree Celsius. Next here rho naught, that is considered as resistivity of conductor at some, we have to take a reference temperature. So here we have to usually take the temperature of 20 degrees Celsius. So you have to remember that in a initial temperature also, that is T naught. So here the alpha is considered as the temperature coefficient of the resistivity. So that is the temperature coefficient of the resistivity. Then the above equation I have to write once again. So rho t is equal to rho naught into 1 plus alpha t minus t naught. It can be simplified, and finally we have to find out the temperature coefficient of resistivity. So here the term rho t is equal to, so inside the term rho naught, so multiply the term to the two terms. So rho naught plus alpha rho naught into t minus t naught. So rearrange that equation. Rho t minus rho naught is equal to alpha rho naught into t minus t naught. So you have to find out the temperature coefficient. So alpha is equal to rho t minus rho naught divided by t minus t naught into rho t. So here rho T minus rho naught is considered as a difference between the two resistivity. So that can be change in resistivity is delta rho, and also change in temperature is considered as delta T. That's why the term can be converted into delta rho and delta T. So delta rho divided by rho naught delta T. So that is considered as the temperature coefficient. So alpha is equal to 1 by rho naught delta rho by delta T. So that is considered as a temperature coefficient of resistivity. So the temperature coefficient of conductors. So for the alpha value is positive, if the temperature increases, the resistivity also increases. So in the graphical representation, the non-linear region, that is the starting region is the non-linear region at very low temperature. So for starting low temperature, it produces the non-linear region, not in a straight line. Then the third point, resistance is directly proportional to the resistivity. So we have to find out the resistivity in the resistance value. So at 0 degree, that is T degree Celsius. So here instead of rho, we have to substitute the R value. So that is also resistance is directly proportional to the resistivity. So resistance here, in previous case we have to find that resistivity, here resistance. So instead of rho T and rho R, we have to substitute the RT and R naught value, and finally we find the alpha value also. Alpha is equal to 1 by rho, that is R naught delta R by delta T. So next, temperature coefficient of semiconductors. For semiconductors, resistivity decreases with increase in temperature. Hence it can be allowed the current is also increases. So a semiconductor with a negative temperature coefficient of resistance is called a thermistor. That is one of the device. So here for a semiconductor, the current value for increases because of the decreases the resistivity for increasing the temperature.